Okay, so today we are going to add small meteors. The idea is that when you break up a large meteor, it breaks up into two small meteors. And then we'll go from there. We'll be breaking up the small meteors to four really small meteors, and then they'll finally go away. That is the plan. One little quick correction. On the make meteors function, we added an actor with meteor.png. And that's totally cool. You're allowed to put the extension. We are doing .png pictures. But it's actually preferable not to, and it could cause some issues in sometimes situations, according to Pygame Zero. So I want to make sure we remove that. You have to do the .png sometimes, but not with actor. So we'll go ahead and take that off. All right. So what we're going to do is we're going to go ahead and make the meteors break up into small meteors when we collide with the missile. So let's go to our collide, check for missile collision. This was a pretty tough little function, but we've got it now. And I want you to go to the place where it says if hit. Currently, all it does is say meteors.pop_i, which removes the ith index meteor because it was detected to collide with a missile. Well, what I want you to do is we're going to ask if its image is meteor. If its image is meteor, that means it's a big meteor, and we need to make two small meteors. So we're going to say M1 equals actor, meteor small. We're about to make that. Don't worry about that. And we're going to set its initial X and Y location at the X, Y location of the meteor we popped. So earlier we have just meteors.pop. Now we're going to say M equals meteors.pop, so that M is the meteor that was popped off of our list. We're not going to draw that meteor anymore, but I want to use it. Mainly I want to use it just right here and right here. And what I do is I take that, and here and there. So I take that meteor's angle and I subtract 90 and add 90. So whichever direction the meteor is going, it is going to shoot off in 180-degree separation. So if it's coming right at you, it's going to shoot out at 90 degrees in the other two directions. If you wanted to continue approaching kind of which way it was going, you could do a minus 45 and plus 45, and then it would kind of fork. And I'll leave that up to you what you want to do. So we create two new actors. We set their angle relative to the angle that the current meteor that we just destroyed is at, and then we simply append it to our meteors list. Now it's time for us to make the meteor small image. Okay, so it's time to make our small meteor. You see I already have one, just for example. But if you right-click on the meteor, you should have options like Edit with Photos, Edit with Paint 3D. I believe you can do Edit with Photos or Edit with Paint 3D. If you choose Edit with Photos, you just don't want to do Edit with Paint because that's going to cause you to lose your transparency. So I go to Edit with Photos, and then I can do a resize here. So that's the aspect ratio. I want to see here, adjustments. All right, for some reason that's not allowing me to do it with photos. I know I've done it with some photos like that, but I'm going to go to Paint 3D. That's the one that I prefer. There are Piskel's an online version that you can use, Piskel. That works really well as well, but it's pixely. It's supposed to be retro. So I'm going to go to Canvas, and then what I'll do is I'll lock the aspect ratio, resize with Canvas, and you put in any amount you want. So I'm actually going to go ahead and make a really small version here. Let's see here. I want to undo that. So I think I'll do like 20 and 20. Oops, see, I forgot that I maintained aspect ratio. So that's a really small one. I'm going to go ahead and save that since I was using an example here as an image. And so I should have meteor, and then I'm going to call this X small. And so now you can see I've got 3 different levels of them. And I'm going to go ahead and put all those, just on in our classroom so that if you have access to that, you can get it. All right, so after making that, you should be able to run your code and hopefully have some success here with creating the different, meteors that, and then what I want to do is I want to make smaller ones occur when we bust these open. So what you're going to do is go back to your check for collision, and you're going to add another layer to this by saying elif m.image equals meteor small. And then if, I'm not a big copy and paste person, but if you want to, you can go ahead and do that and make it extra small. And so now we're going to have that additional layer to it where we can bust them up several times. And I don't know, I hope you think these extra small meteors are I think they're small enough. Yeah. You don't want to make them too small probably. And that's it, pretty much. All we need to do now is make it to where the meteors collide with our ship, blows up our ship. But before we do that, we are going to have to make some changes to the initial setup of the meteors. So the problem is when we create our meteors, here, we just picked any random place at all. And that's not really good. It should really be right on the edge of the screen and then come into us so that we give our ship time to react. In this case, it's even possible that a meteor could just come into existence right on top of our ship and destroy them, and that's certainly not fair at all. So what I want to do instead is I want to make it appear on the edge. So we're going to make 4 different situations, okay? My first situation would be appear on top edge. So I'm going to say random, I'm going to call it choice. And I'm going to use my randint 1, 4. Because I have 4 different options. Either it's going to appear on the top edge, the left edge, the right edge, or the bottom edge. Oh, I didn't mean to put a colon there. So if choice is equal to 1, we're going to call that the top edge problem. So if it's on the top edge, then I want to set... Oh, you know what? We need to move this up here. Sorry. If it's on the top edge, well, then what I need to do is set my rand y to 0. And that might seem weird. We just found the random y. Yes, but one of those values needs to be 0. If it's the top of the screen, the y is 0. Elif the choice is equal to 2. That means we picked a random number from 1 to 4 and we got a 2. Then let's make that the bottom of the screen. If the choice was 3, well then let's make that the left-hand side of the screen. And else, there's only other one case, so I'll just say else randx equals width. So now we're forcing it. We're choosing it. We're still choosing a random x and a random y initially, but we're changing those values to be either far left, far right, far top, far bottom, based on whether our random int 1 through 4 was a 1, 2, 3, or 4. And there's lots of different ways we could have done that. That's just kind of one way to do it. And then everything else is going to stay the same. And that's just our initial meteor construction. So let's just run that, make sure that behaves the way that we are hoping. And hopefully you'll see that there's no meteors immediately near you. And so then they kind of slowly come into view, right? All right. There we go. And I'm just over here cleaning up space. And there you go. Game over. All right. Let's now make it to where we blow up if we get hit. So we'll do that. Okay, so I uploaded to my classroom the about 9 different explosions, and I'm just going to take explosion 00, and I added it to my images folder, and I just renamed it explosion. Now, they have a cycle. If you want to use a timer, we know we have the Pygame 0 includes a timer that can call a function after a certain amount of time. And so what we can do is we can tell Pygame 0 to change the image of the explosion after, so many, fractions of a second, giving us that moving explosion kind of image. But I'll leave that to you as a challenge to do. Just look at the Python docs, the Pygame 0 docs to see about how to use that schedule unique timer situation. All right, but for us, let's just take a look at the explosion. So we have that, and what we're going to do after checking for missile explosion, we're going to check for rocket explosion. Okay, and this is not nearly as hard as for the missile. That was a pain, right? So to check for rocket explosion, you just simply check and see if there's any meteor that's colliding with your rocket. And if there is, then we can end the game. All right, so what I'm going to do is I'm going to make a variable here called alive. All right. I'm going to go to my update. All right, and I'm going to say if alive then we'll update our rocket. So we're now only going to allow our rocket to move around if we are alive. So when we check for rocket explosions, we're going to loop through all our missiles. Since I won't be all of our meteors, since I won't be changing or erasing, I can do just a simple for ion range Lin meteors. So I'll simply loop through all the indices of the meteors. If meteors, bracket I, the ith meteor, is collide recting with my rocket, then rocket.image needs to equal explosion, and alive needs to become false. Yeah, hey, I'm sorry, y'all. I Java'd. You have to forgive me. I teach Java 3 out of my 4 computer science classes, and this is a unique thing to Python. Like most things that are different in Python, it actually makes sense and is really, really smart, which is why Python is taking over the world. But alive is not assigned to a rocket. We'll do more stuff like that later. It is a global variable, and so it thinks I set a local variable. I need to say global alive. That's why I was still able to run around. Okay, just a quick statement. Earlier in the video, we showed that I wanted you to change this to when we create our meteors in our make meteors function, make it just meteor, not meteor.png. And the reason why that's important to do that is that when we check to see what kind of image it is here, it needs to be just meteor. So if you're having trouble getting the small meteors to appear when you hit them, make sure that you've changed that. Okay. The last thing I want to do is we're going to de-spam the missiles. So this is a common technique that we can do. Now this only works because we remove our missiles from the screen, from the list when they go off the screen. But currently, I think the game is actually a little too easy. Because you can just, that's kind of ridiculous, right? But if we limit the number of missiles that can currently be out, we can limit it to just one. And that would make the game very challenging. But you can limit it as much as you want based on how many things you have. By asking, when they fire, ask if the length of the missiles list is less than some number. So that would allow only 3 missiles. Because you're only letting them add if they have less than 2. So now when I run it, I should be able to fire 3 of them. Well, I forgot my colon. It's not going to like that. So now I should be able to fire. Oh, I can only fire 2. Never mind. Okay, so there you have it. That's the story. So what I'm going to suggest that you do, add sound effects. You could add it to where when there are no more big meteors, another big meteor comes up. So when there's no big meteors, that you can add another meteor. And you can also add a score variable. And you could add lives. So I leave that to you to figure out and have fun with. All right, so I wanted to add just one more little bit. Some people were complaining that the hitbox on the rocket was a little too large. If you go to the check for rocket explosion, meteors bracket I dot collide rect, you can change it to collide point and give it the rocket position. The problem there is that then the meteor has to be over your center of your rocket. But since the meteor's collide box was kind of big compared to the image, you might find that more realistic. You want to get more exact than that, you got to write your own collision function, which involves, getting the 2 different points, constructing your own little hitbox rectangle and all that stuff, which is so much fun, i.e. tedious. I'll let you do on your own. Good luck, though.